This conference will now be recorded.
Okay, today, as I told you, I want you two guys to do it a prime number. Okay, today, maybe like and tomorrow, we'll be dealing with the programming itself. Okay, I want you to be very much good in programming within this 3 days. Okay, so now, what's the date today? Today, 23rd, 09 and 20, right? Gaurav is ready with the date. That's nice. Okay, so write a prime number, guys. I'll give you 5 minutes. Think the logic for the prime number. Prime number. Think the logic for the prime number. Okay, we'll do this today very much perfectly. Okay, so you will get the real logic of the programming today. Okay, how to reduce it, how to cut short it, everything you'll get to know today. Those who didn't watch the Armstrong number, I will remind you, watch it Armstrong number, because over there I have explained the logic for power, for the length also, which we have done it already. Same logic we have explained over there, and again some other thing of the Armstrong logic. Okay, so in that one single program we have explained other things also, so just go for it while doing the prime number, right? Don't recall the logic of the previous program which you have written it. Okay, I want you to think it from the scratch. Okay, think it from the scratch, that will be good. Let's start it. Now guys, I will take a numbers. Let me take it a number like this: 1 2 3 4 5 6 7 and 8. Okay, I don't know what is prime number and what it is. I don't know exactly what it is, and now I'm trying to understand it. What is the prime number? Okay, before starting that, I'll just check it out, the factors of this one. 1 का factor कितना है? 1 का 1 है, right? 2 का factor क्या क्या है? एक 1 है और एक क्या है? 2 है, right? So these are the factors. 3 का factor क्या है? एक 1 है और एक 3 है, right? What is the factor of 4, guys? 4 का factor ऐसा है, 1 है, 2 है, and again 4 is also a factor, right? 5 का factor क्या क्या है? 1 and 5, simple as it is, right? 6 का factor क्या क्या है? 6 का factor है 1 है, 2 है, and again 3 है, and again 6 है, right? 7 का factor क्या क्या है? 7 का factor just 197, right? Just 197. 8 का factor, 8 का factor भी 1 है, and again you have it 2 है, again you have it 4 है, again you have it 8 भी है, right? So on, right? So after seeing this, you got one rough idea which is prime number and which is not prime number. Tell me, guys, which is prime number? Which are the prime numbers? Which are the prime numbers? Okay, so I can tell it by seeing this. Okay, so you know the definition. What is the definition, guys? The prime number has it. What is the definition the prime number has this? Has this? Whose only two factor, right? So the factor should be 1 and itself, right? 1 and itself, right? So okay, that's okay, fine. 1 and itself. Yeah, according to me, I will tell you how it is. Okay, so if after seeing this, I will tell you my own definition. Those who have two legs, okay, those are all called as prime number. Those who have less than or more than, right, those are all not called as prime number. For example, this one, does he have two legs? No, then this is not a prime number. Does he have two legs? Yes, this is what the prime number is. Does he have two legs? Yes, this is what the prime number is. Does he have two legs? No, this is not a prime number. Does he have two legs? Yes, it is a prime number. Does he have two legs? No. Does he have two? Yes, this is a prime number, right? So here 7, 5, 3 and 2 are the prime numbers, right? 7, 2, 5 are the prime number, right? Now how I can think it, what is the logic I want to think it, right? So look onto this, guys. Look onto this simple thing. I will tell you, I will read one number, right? I will read one number. Maybe like, for example, I will tell it has like int n. I will tell it n is equal to 6. I will tell it, right? N is equal to 6. I will tell it. Now when I tell n is equal to 6, tell me guys what I'm doing it. I'm checking with all the numbers, right? So what I'm doing it, I'm starting from like 6, whether 6 is like modulus of 1. 6 is modulus of 1, right? I'm checking with this, I'm checking with 2, I'm checking with 3, I'm checking with 4, I'm checking with 5, I'm checking with 6, right? Where all it get right mark, here it gets right mark, here it gets right mark, and here is also gets right marks. So over and here no, and here no, right? You will count it all the things, right? You will count it all the things, right? And later on, after this what you'll do it, after this what you'll do it, you will check it whether my thing is belong to, whether it is equal to 2 or not. If it is exactly equal to 2, then it is a prime number, else it is not a prime number, right? I have read the number, now I want to do this operation. I want to do this operation. What is the operation? I want to start it from 1, I want to end it till 6. Remember this, I want to start it from 1 and end it till 6, right? I want to do this operation again and again. Right, what is the operation I'm doing it? I'm just checking it out. N modulus of, I'll just set it as for 6, I'll just set it as n modulus of, since it is 1 2 3 4 5 6, right? I will take I variable where I varies from 1 to n. I will tell it. For this I'll write a for loop. For this I'll write a for loop. Now what I'll do it now, I'll come here, I'll just set it as for, I'll just set it as integer int I is equals to what, guys? I'll start it from 1. I'm not starting from 0. I will start it from 1. I'll just set it as I less than or equals to n. I will tell it I plus plus. Okay. Everyone control it. Control it. Okay. We'll be doing it. Okay. We'll be doing it. I told you, right? From starting from the scratch, in the worst case, we'll be doing it. Got it? Over then we'll be doing it. Okay. Now what I'll do it, n modulus of I, right? So n modulus of I, which is equal to 0, I'll check it. If it is 0, if it is equal to 0, what I need to do it, I need to count it. Oh, 1 time, oh, 2 time, oh, 3 time, oh, 4 time, right? I will take one variable called as count is equal to 0. So I'll make it as like C++. Any queries still here, guys? Any queries still here? You got to know I'm taking a, whatever the number is. I'll take 2 3 4 whatever the number is, and after that what I'm doing it, I want to check this number with 6 modulus of 1, 6 modulus of 2, 6 modulus of 3 from 1 to itself, right? Till then I will check it. If any one of the number it divides, right? If it is more than 2, if it is more than 2, then it is not a prime number. If it is less than 2, it is also not a prime number. If it is exactly equal to 2, then only it is a prime number, right? And you got to know why I'm taking this I value, right? So you got to know why I'm taking this I value. Why I'm taking this I value? Because of this reason. This is the reason, right? So instead of writing this again and again and again, I'm just putting in the while loop, right? Even if I read 100 here, it will run till 1 to 100, right? So it will become what? Generalized, right? So next line, what I need to do it, this is done. This is done. Later on, I'll check it something like this, right? So if it is like C equals to 2, I'll put a question mark here. I'll just print it as what? Printf. Printf, I'll just set it as prime, else I'll just put it as not a prime number, right? The same logical things. What I'll do it now, I will go and I will update in my program. Done, guys? So I'll come here, I'll come back, I'll just set it as vi day16.c, right? vi day16.c. So I'll just set it as like hash include hash include stdio.h, right? .h. I'll just set it as int main, right? I will enter this, right? So what I'll do it now, I'll just set it as int n. I wanted it. Okay, I will not declare this. So what I'll do it now, I want to read this number. I'll just set it as scanf percentage d. I'll just set it as address of n. You know why it is address of n, right, guys? Address of n. Later on, what I need to do it, guys? What I need to do it? I want to iterate it. For which one I want to iterate it? That condition is there, right? For that, what I'll do it? I'll write it for loop. For int I starts from where, guys? I should start from 1. I should be less than or equals to what, guys? N itself. I'll just set it as I plus plus according to this logic, right? So I'll come here. What I'm checking it, if what is that condition? If n modulus of I, if it is equal to 0. Can I write it like this also, guys? If it is n is equal to 0, can I write it like this also? Can I write it like this also? If it is a negation here instead of 0, can I write it like this? Right? I'll just tell it as C++. Right? I'll just tell it as C++, count plus plus. Right? I will initialize count equal to 0 here. Done? Simple as it is. Right? So I'll come below. Now what I'll do it? I'll come below. I'll just tell it as I will use the ternary operator. If it is C equals to 2, exactly equal to 2 legs. Right? If it is exactly equal to 2 legs, I'll just set it as printf. I'll just set it as prime. If it is like that, if it is like that, I'll just set it as prime, right? So colon, or else I'll just set it as what? printf printf. I'll just set it as not a prime, right? So I'll just give a number, right? So I'll just give a number percentage d here, so that it will be good to look onto it, right? So it will be good to look onto it. So I'll come here, same thing I'll do it here also. Prime equals to percentage d, right? So I'll just set it as n here, right? I'll just set it as it's prime number. 26 is prime, right? So I will print it like that, in that way, right? So I'll print it in this way. Percentage d is prime, right? So this will be good, sounds good. So same thing, I'll just select as here also. Here also I'll just select as here. Percentage d is, right? Percentage d is not a prime, right? So same thing, I'll do it. Now I'll run this program. I'll just check it out, whether it will working on, whether it is working or not, right? How easy it is, how easy step it is, right? So if I go for here, if I go for the program, I still remember, guys, those were the days when I wrote the first prime number, right? What I used to think is, okay, if it is modulus of 1, if it is modulus of 2, done, right? So else you do with it, right? Even I have done the worst things, right? If I look back to that, I can only laugh at. 6 is not a prime number. I just realized 13. 13 is what? A prime number. You tell me what are the numbers, right? Maybe like 1000, you tell it. 1000. 1000 is what? It's not a prime, right? Within 1000, which is the highest number, guys? 997 is the highest number. It is a prime number, right? 997 is the highest prime number within 1000, right? So this is working. So this is working fine. This is working fine. Okay, just check it down. Just check it down. Okay, just check it down. Take it down. Take it down. Take it down. We'll do this certain modification over here. I'll tell you what is the modification, why I'm doing this modification. So this is a simple level you'll think about the program. In the worst case, or in the worst case, you just want to get the output. At the time, you think in this way. Okay, because I'm going for the next level. I'll be taking one variable, a dummy variable, which is not actually into the prime number. Okay, this I'm taking for a reason. Okay, not to worry about it, just to count it how many times the condition things are running. Okay, just to track about it, I'll be taking this. Okay, I'll just take it as z is equal to 0. Okay, z is equal to 0. I'll just take it a variable called as z. Okay, why I'm taking the z? Because to traverse it, how many times it is traversing it. Okay, so I'll come here. Here the for loop will run all the time. So I'll just set it as here also z plus 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 I will tell it. Okay, there is no role of anything with the respect to the prime number. It's just a variable I'm taking it. Okay, so this will execute at least whenever the condition is true, right? This will execute at least whenever the condition is true. Inside this one also I'll write it z plus plus, right? And again this condition will execute at least one time, right? So that I'll tell it as z plus plus here. At final, I'll just print it z. I'll just print it percentage d. I'll just print it z. Done, guys. I'll just print what? Z. Now I'll run this program. I'll run this program. Okay, so I'll compile this program. I'll compile it and I will run this program. For example, guys. Now if I tell it as 10, if I tell it as 10, how many times it is running? 15 times the thing is running. To tell just a not a prime number, it is doing all the 15 times dramas, right? So if I tell it as again, if I run this one, for example, I'll run for 1000. Let's calculate for the 1000. Okay, for 1000 it is running 1017 times. It is running how many times? 1017 times. Okay, now coming to here, I'll just take it as 997, right? 987. To calculate, it's a not a prime, it's a prime number. To tell it's a prime number, it will run how many times? 1000 times. There is a problem here. The program is no problem. Okay, this program works fine for all the numbers. There is absolutely no problem. But we are doing some what is that? We are doing some unwanted traversing thing. Okay, iteration we are doing it. Unwanted iteration we are doing it. We are checking unwanted condition we are checking it. Got it? So that one I want you to reduce it. How you can reduce it? Got it? If you think it at the beginning itself, if you think about the reduction, you won't be solving the problem, right? First solve the problem. After that, give the efficiency for that. But this is how you go for it, okay, step by step. Okay, so I'll think about the solution now. Yes, I'll just tell an equation for you. If you have an equation called as x square plus x, right? How do you write this equation? You'll take x as a common, right? So x common, you'll take it, you'll tell it as x plus 1, right? Same thing I'll be doing it here also. What are the common things which you have it? One is common between everything. One is common, 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 and one is common, right? Other one is itself, 2 itself, 3 itself, 4 itself, 5 itself, 6 itself, 7 itself, 8 itself. It's common between everyone. So I'll take down this one. 4 itself, 5 itself, 6 itself, 7 itself, 8 itself, right? Now tell me what is the logic for the prime number, guys? Now tell me what is the logic for the prime number? It is very much easy to modify now. Okay, now it is very much easy to modify now. Look on here. Instead of I started from 1, now onwards I will start it from 2. Look on this, the number will always start from 2 for all the things, right? Number will always start from 2. Okay, I don't want to write less than now, less than or equals to now. I can only just tell less than, that's it, right? Because itself is also gone, all right? I can tell that less than now, all right? One more modification is when it is a prime number, guys, when you don't have a lex. That means if c is equal to 0, or else you can tell it as negation of c. You can tell it either you can tell it c equal to 0, or else you can tell it as negation of c. You can tell it, right? So what you are doing it, so you have no legs, no legs, no legs. That means it is a prime number. Those who don't have a legs now, those are all called as prime numbers, right? This guy have a leg, this guy have a leg, this guy have a leg, right? So it is not a prime number, right? It's not a prime number, right? To check this, where I want to start it from, I want to start it from n. I don't want to check it itself. I don't want to check it 1 and itself now, right? I will remove that 1 and I'll start it from 2, because this one is starting from 2, right? So, and I'll tell it as less than n. Problem solved. And here I'm changing it to what? Negation of c, right? So same thing I'll do it. I'll come here. What are the modification I want to do it, guys? Here I want to change it. It should start from 2, and I don't want this less than or equals to. I don't want it, right? So here I will come here. Okay, c++, that's fine. Here what I need to do it, I need to do with the modification of whether c equals to 0, right? Now I will run this program. Whether it is the same output or not, right? So I'll just tell it ./a.out, out, right? I'll just tell it as 2 is a prime number, only one time it is running, right? I'll just tell it as for 1000 now. Okay, I'll just tell it as for 1000. Look at this, guys, for 1000. It is running. How many iteration I have reduced it? From 1017 to 4 iteration I have reduced it, right? 1017, 1013 we have reduced it. We have done something, right? So we'll be going to do some other things also. 997, right? So how many times? 4 times we have reduced it, right? 4 times, 4 iteration we have reduced it. 4 time checking we have reduced it, right? So take down, this is one more update thing. There's one more update, right? This is one more update, right? What are the update we have done it? I is equal to 2 and n is equal to so and so, right, guys? Right, guys? Okay. So one more update we can do it. I'm not satisfied. I'm not still satisfied with that. Okay, I'm not still satisfied with that. Okay, now what I do it, guys, is I'll tell you one more thing, guys. I'll tell you one more thing. Okay, what are the highest factor of this one? And it's L50. What is the highest factor of this one? This one factor is 25, right? So if I tell 100, what is the highest factor of this one except itself? Half of its number, right? So half of its number, right? 50, right? If you from 51 to 99, okay, from 51 to 99, if you do your leg down and head up, or head down or leg up, okay, whether do you get a factor for 100, guys? Whether you will get it? You will not get it, right? Then why I want to check this? Irrespectively, why I want to check this? Right here also I'm checking it. Okay, I know here 4 is the highest factor. I'm checking for 5, I'm checking for 6, I'm even checking for 7. Why I'm doing this? Simply I'm doing this. right? I don't have any other work. I'm doing it. Same thing for 1,000 also. Look on this for 1,000 also. I know till within 500 is the highest factor it has it, but still I'm checking it. Still I'm checking 501, 502, 503, 504, right? So what I want to update is, I want to update like this, n divided by 2, right? Till n divided by 2. So here also I'll come here and I will update it something here. The logic is, what is the logic I'll update it? Here I'll just set it as equals to n divided by 2. N divided by 2. Do it till you get the half of its number. Okay, after that you don't check for it. Okay, that is a small logic which I'll be updating it. Okay, now by that small logic, you just check it out. What is the difference you get it? Okay, by small changes with the logic. So I'll just check it out. What equals to, I'll just set it as n divided by 2. When I tell this one, guys, when I tell this one dot slash a dot outr, right? I'll just set it as 1,000 now, right? When I tell 1,000, guys, just imagine what will be my iteration condition. So if I enter this, it is telling that 514 times. Just look onto it, guys. 1,017, where it was 1,017, where it is 514, right? We have reduced to half of its iteration. For example, we'll do it for this one also, right? 997. Look on this, for 997, it is getting you what? 498. My half of the time is reduced. Just imagine for 1 lakh, it will reduce for 50,000, right? 10 crore, 5 crores. Okay, I'll just give you one example. Look on here, guys. There is a relative's home. Okay, there is a relative's home. Okay, now you will go to the relative's home. Okay, when you're going near the doorstep, okay, they will tell you act through. Okay, they will spit on your face. Okay, whether you will go inside the home. No, our relatives. I will wipe my face and then again I will go. Again you will go. Again you will go. Again they will do act through. Then again you will go inside. Again you will go. No. They are my relatives. Again they'll act through. Whether you will go it, guys? Yes or no? That's more than enough. Whether you will go or not. Once they to tell act two, okay, whether you will take it as a u-turn and you will come, or else you will wipe your face and you will go inside, right? Self-respect, right? You will never ever go, right? You will never ever go, right? You will not go, right? Pakka 100%. सुदर्शन को फ्लैशबैक याद आ गया शायद रो रहा है हाँ? कोई क्या था क्या ऐसा mask will be helpful. Oh, Ankit is telling lies. Sir, we'll put mask, sir. Shameless fellow. Okay. So look at this, guys. Okay, why I'm telling you this? Because you got to know 6 modulus of 2 is not a prime number. It is condition is true, so it is not a prime number. Again, you are checking, you are wiping your face. Again, you are going and you're checking for 6 modulus of 3. Right? So next time also you're checking it, right? Next time also you are checking it, right? This is what the mistake is. Once you got to know this is what it is. Once you got to know this is what it is, right? So once you got to know, okay, 6 modulus of 2, it is getting into that. You don't want to check one more time. Got it? For example, here look on here, 8 modulus of 2, right? The condition is becoming true, right? Again you are checking for a 8 modulus of 4. All right, these things we should not to do this. Okay, to stop this, what I do is I'll tell it, when this condition at least one time it becomes true, right? I'll just come and apply a statement called as break, right? If I apply this break statement, guys, it will come out of this loop. I'll be not checking for the other things, right? One time they will spit it on my face. I'll apply break and I will come back. I will never go again, right? So that is what you will keep it. Okay, so other things like you apply mask, sir, they are relatives, sir, we need to go again and again, you go for it, right? Who cares about it, right? So when I apply break here, look on this here. Look on this, I apply a break here. I'll run this program I'll compile this. I'll just tell it as dot slash a dot void, right? So now what I do is I'll just tell it as 1000. Do you imagine, guys, what is the iteration I'll be doing it? If I enter this, I'll be running only for 2 times, right? Just imagine to find a not a prime number, it is more than sufficient with a 2 iteration. Okay, just imagine where were we, like 1017, we have reduced to 2 times, just 2 iterations, right? Same thing we'll be doing it for other things, other number also. For 997, for a prime number, it is remaining as it is 498 times, it will remain 498 times itself. Okay, so just take it down. We have reduced it to, if it is a not a prime number, we have reduced at most maximum 3 it will go. Okay, at most maximum it will go 3. Above that it will never go. At most maximum it will go for 3. That's it. Above that it will not go. All right, but there is a problem for a prime number. Okay, that we will look forward for it. That we have a solution. We'll look forward for it. Okay, so this is your program. This is your prime number program. Just take it down. Just take it down for a not a prime number. How we can reduce the logic? Think about it. So this is the next level which we are going now. Okay, hint is, guys, what is the hint is? Look here, if I give a hint also, you need to go for a long way for it. Okay, so what we do is, for example, if I take a 900, guys, if I take a 900, I believe that then 450, okay, then 450, doing this 450 in the sense n divided by 2. Okay, doing this n divided by 2, we can do it something called as square root of n. What's the square root of n? 30. I believe that, okay, within 20 to 30, 2 to 30, there will be at least one divisibility. If you don't find at least one divisibility, then it is a prime number. If you found it at least one divisibility for this, then it is a not a prime number. Okay, same thing for 997. 997. Okay, I will only find it till square root of the number, square root of this number. Right? If I found it with the square root of within the square root of number, I can reduce my iteration. So my logic is to find out the square root. If you find out the square root, that's well and good for you. You know how to find the square of the number, right? So 9, or maybe like to make it a 9, to make it a 9, how do you make it? How do you make it? So you will tell it as 3 into 3, right? 3 into 3 equals to 9, right? To find the square of the number, it is easy, right? 3 into 3 is equal to 9, right? Square root is just a reverse order. Just apply the reverse engineering for this, you will get the logic for it. So when it is 3 into 3, it is 9. When you are giving input, when you're giving 3 as an input to find the square, you will do this one. Now when I give an input called as 9, okay, you need to get an output called as what? 3, right? How do you do this? How do you do this? Right, when you're telling 3, you are getting 9. There is a square of the number. That's okay, fine. You're just doing simple logic. How do you find it of the square root? How do you find it for the square root? The simple logic you need to apply for it, implement for it. Look on here, guys. I have 9. I have 9. Okay, I have 9. I will just check it out from beginning. I'll check it out whether 1 into 1, whether it is less than 9, whether 1 is less than 9. No, I'll check it. 2 into 2, whether it is less than 9. 4 is less than 9. 4 is less than 9. No, again I will increment it to 3 into 3, whether 3 into 3 is less than 9, guys. 3 into 3 is less than 9, guys. Yes, it is less than. The condition becomes what? False. It is not less than 9, right? It is actually less than or equals to 9, right? So 9 cannot be less than 9, right? This condition becomes false. At this condition become false, I'll get this 3 here. Same thing for 25 also, right? So instead of 1 into 1, I'll just tell it as what? I into I will tell it. I into I, whether I into I less than 9, right? I starts from where, guys? So I'll just apply the for loop for I equals to 1. I'll just condition tell it as I into I less than 9, I will tell it, and I'll just tell it as I plus plus, I will tell it. I plus plus, I will tell it. That's it. Each time it is incrementing by 1, right? When it is 1, it is coming to here. 1 into 1 less than 9, condition is false, it will come to here, and I'll tell that increment it, and again I will come to here, right? 2 into 2, no, 3 into 3, condition becomes false. I'll come out and I will return what? I'll tell that return return, I will tell it, right? But when I tell this, it should run in one single line. To run this for loop one single line, I will apply this semicolon over here. If I tell semicolon over here, that means it need to complete this statement first. Completely, it need to complete this statement first. Then only it will go for the next line. If I don't put this semicolon, right, it will treat this one as its own line. For loop, you need one statement, right? Whenever you're writing a loop, you need one statement. Whenever writing if, you need one statement, right? For loop, if I apply the semicolon, right, it will never take this as a statement. It will execute this complete line, complete statement. After that, it will come to this line. Got it? Only so much logic. I'll come here. I'll just tell it has like SQR. I'll tell it SQRT. I'll tell it, right? So it will accept N. It will accept N. I will tell it. I'll come here. I'll write this. So simply here, what I'll do it now. I'll just tell it as for loop. I'll tell it int I equals to 0. Int I equals to 1. I'll tell it I into I is less than what? N. I will tell it. I'll tell it as I plus plus. Right here, what I need to do it, I need to put the semicolon. After the semicolon, I'll just tell it as return I will tell it. That's it, done. Your square root logic is done. So what I is nothing but what? Integer type, right? I is nothing but what? Integer type. So what I'll do it now, I will need to return I, guys. Okay, at this time it is a catch, guys. Why? Because the scope of the I is within this for loop itself, right? I will get a slap now. Now what I need to do it, so to get it entire program, I want to get this I as an entire program. So what I'll do it now, I'll declare I as a local variable. Int I is equals to int I will tell it, so that it will be easy for you. And I is an integer number, so I'll just tell it as int. Okay, so I'll come here, I'll define this program. So I'll just tell it as like integer sqrt square root of, I'll just tell it as int I'll tell it, right? Now what I do it now, instead of writing here, I'll just tell it as sqrt square root of n. I will call it, right? When I call this program, what happens is compile it. Oops, it's a warning. Sqrt, what is this? Sqrt is a built-in function. That's okay, no problem. Dot slash a dot out. So I'll come here, right? I'll just tell it as 997, right? When I tell 997, what I've reduced to? I've reduced to 32 digits, right? Same thing, I'll do it for 1000. I'll do it for 1000. It is telling you what? Two times, right? Now, what I do is like, this is a bad way of writing a program, guys. This is a bad way of writing a program. Whenever the loop calls it, this is calling the function, right? This is a bad way of writing a program like this. Okay, so whenever I call this loop for first time, it will go and execute this function. Again, this loop is calling this one. Again, it will go for this function, right? Instead of that, what I can do is, I can simply tell it as like this. Got it? I can tell it as like this. So I will remove this. And I'll just tell it as int s is equal to sqrt of n. I will tell it, right? Sqrt of n. I will tell it. So what I'll do it now here, I'll just tell it as s here, right? So before that, I'll print it. I'll just print it s. What is this s is? Printf %d. I'll just tell it as /n, and I'll tell it as s. So just for our understanding, guys. Okay, neatly I need to write this program. I'll show you how to write this program. So I just tell it as dot slash a dot out out, right? I'll just tell it as 1000. For 1000, what is the square root? I'm getting it has what? 32 has a square root. For 997, maybe like 900, I'll just tell it as 900. What is the square root? I'm getting it 30 square root. I'm getting it, right? For 997, right? Somewhere around 32 I'm getting. It should come 31 point something, but I'm getting 32. That's fine, no problem. Got it? So for example, if I tell it as 35, right? If I tell it as 35, it will get me 6. Okay, it will get it 6. I need to get it what? I need to get it what? I need to get it something around like 5 point something, but I'm getting 6. No, nothing to worry about. Logic should be something like this. Okay, I into I less than n. Okay, the same logic what I have written it here, right? The same logic should be over here also. Okay, so what I need to do it, I need to come here. So what I'll do it now, I'll compile this. I'll just set it as dot slash a dot out out. So I'll just set it as 7. Okay, I'll just tell it as 7. 7 is a prime number, right? So if I tell it as compile this, I'll just tell it as like dot slash a dot out out. I'll just tell it as 1000 here. So it is not a prime number. I'll just set it as 997, right? It is nothing but it is a prime number, right? Same thing, I'll do it for 2 now, right? For 2, what I'm getting it? I'm getting it what? Prime number. Why I'm getting prime number? I told you, right? I will shift the logic. This logic, entire logic, I'll shift it, right, to the above. So that's the reason it is coming to 2, right? So if I write the logic here, if I have written the logic here starting from 2, then it is fine. Then also it was fine. Okay, just a changes. If I write it here 2 also, then it will work it fine. The same thing I am doing it here also, right? Now what I did is, like, by using this logic itself, we can achieve this constraints, right? Now what I will do is I will reduce all these things. Okay, listen up this one. I'm almost end of the program. I will remove all these things. I don't want this. So since we got the logic of this one, so again I will remove this one, right? Instead of this one here, I'll write a function for a prime. I told you I'll be not writing any logics in the main function, right? I'll just write a prime number, int prime. I will tell it int prime. I will tell it. It accepts one parameter, so I'll just set it as like this, right? Now tell me, guys, whatever it is there from here, you just tell me the logic. What is the logic it is? So I wanted something like this here. What is the logic I wanted here? What is the logic I wanted here? Okay, I wanted int c. I wanted it, or else I don't want int c also here, right? So straight away I'll come here. I'll just select as for. For I'll tell it int I is equals to 0. I'll tell it I is less than, right? I is less than, what I'll do it, I into I less than n. I will tell it, and I'll tell it as I plus plus, right? So what I need to do it, if the condition is true, right? If what is that, if negation of n modulus of I, if negation of n modulus of I, if it is equals to if it is like this, right? So what I need to do it is, I want to do something here, right? I want to do something here, else I want to do something over there, right? The same thing I'll be doing it. Okay, now listen up this one, guys. What I'm writing is, if it is becoming true, guys, if this is becoming true, I will return retur and return 0. I'll tell it, right? If it is satisfyingly done with the complete iteration, right, I will tell it as a return 1. That's it, I'll be doing it. Okay, so over here I will eliminate all those things. Over here I will eliminate all those things. I know it is a complicated now for you, so it will be, I'll make you easy now, right? Is that any necessary for z now? I don't want anything with the z now, right? I don't want to do anything with c also, right? So here what I do is, I don't want this z, I don't want this, I don't want this one also, right? Now where do I call this prime number? I will call this prime number logic over here. So I'll just simply tell it as, I'll just set it as prime, right? So I'll just let as prime of, what I will do it, what is that number? N, whatever the number you are calling it, right? Prime of n, I will tell it. When I tell prime of n, right? So when I tell prime of n, so I'll read it and I'll get the point. So simple thing, this is the logic for your prime number. This is the logic for your prime number. That's it. Simple. That 3-4 lines is a logic, right? So if it is getting one time, okay, so 1000 modulus of 2, yes, then what I'll do it, I'll return 0. This becomes 0 now, and will print it what? Not a prime number. Now 997, it will never go inside this one, right? At last finally it will return 1. So when it is returning 1, it is telling that condition is true and printing this one. That is what the logic I'm doing it, right? So I'll come to here. So compile this. I'll just set it as ./a.vout out. I'll tell it has I is equals to 2, right? So I'll just set it as 1000. I'll just set it as 1000. Oops. Where I went wrong? Okay, I is equal to 0. I told it. So I'm getting the exception, right? So floating, right? So I is equal to where, guys? I is equal to 2. I'll tell it, right? So I'll just come here, compile this ./a.vout out. So I'll just let it as 1000 here. So it is not a prime. So I'll tell it as 997. So it is a prime number. So if I tell it as 2, it is a prime number. If I tell it as 3, it is a prime number. If I tell it as 4, it is a, oh, for 4 it is coming prime number. Ha ha ha. Right? So this one I want to accept it, right? This one I want exception. This is a quite an exception for me. So remaining things, it's okay, no problem, right? Remaining thing, it's okay, no problem. So just for the 4, I'll be getting it like this, right? So just for the 4, right? So 4, what I need to do it, I need to come here, I need to accept this. So I'll just tell it as equals to here, right? So I'll just come here and I will tell it as equals to here. Look onto this. I'll come here and I'll just tell it as equals to here. If I tell equals to here, now let's look onto it. compile this dot/a.outr, right? So if a delta has like 4, right, delta has 4, it is not a prime number. So if a delta has 2, it is a prime number. If a delta has 3, right, it is a prime number. If a delta has 997, it is a prime number. If a delta has 1000, it is a not a prime number, right? So this becomes very much easy for you to write a program. Okay, this is your ultimate program for you. Okay, so sir, if I want to do the iteration, right, if I want to do the iteration also, you can do it in a proper order, right? For example, you can do it like this. Sir, I want to find it from for, you can apply here, you can tell it as int I equal to you can start from 2, right? And you can tell it as I less than, what you can do it, I less than or equals to n, you can tell it, equals to n, you can tell it, and you can tell it as I plus plus, right? I plus plus. This becomes what? I will send it now I here. What happens when I send I now here? What happens when I send I now here? So instead of n, I'll send it I now here. What happens now when I send I here? It tells me what are the numbers you have it from 2 to n, right? Which all the prime number, which is not a prime number, which all the numbers are prime number, which all not the prime number, right? So 2 to 100, you can run this program. So I will compile this and I will read this program, right? So I'll read this program. I'll tell it as 100 till 100. You tell me what are the prime numbers, what are the not prime numbers. Oh, it is only matching for 100, 100, 100. Oh my god, right? So I want to check this condition. So I'll go for here. So what did I do it? So I have done it. What I have done it? Okay. So simple thing, guys. So I'm getting it properly, but what I'm printing here is not n. I should not have print n. I want to print it what I here, right? I want to print it what I here. I want to print it what I here. So if I go for here, so if I tell this compile dot/a.out, so if I tell it has 100 here, so I'll get it all the numbers, right? So when you look on this, 97 is a prime number, 98 is a not a prime number, 99 is a not a prime number, right? So I'll get all the list of what, all the list of what, all the numbers. I can even tell it as 50,000. I can even tell it as 1 lakh also, no problem with that. Sir, I don't want the not a prime number, sir. I need only a prime number, sir, right? What I'll do it now, so I'll just simply, I'll go here, I will remove this. Where I will remove this one thing, this thing, I will remove this. I'll remove all those things. In ternary operator, can I write it a ternary operator without a false statement, guys? Can I write a ternary operator without this? If I do this, guys, I get a beautiful slap. Okay, I'll compile this, I'll get a slap telling that expected expression. All right, expected expression. So what I do is I will come here, I'll do it something like this here. I'll do it something like this. I'll just tell a dummy statement. I'll tell it dummy statement. Simply, I'll tell this dummy statement. Now, if I run this program, guys, okay, now if I run this program, look onto this. So what I do is I'll just tell it as 100 here, 100 here. You just check onto this, all the prime numbers from 1 to 100. I get it, right? So I'll just tell it as 1000 now, right? So all the prime numbers from 1 to 1000, I'll get it. All the prime numbers range, right? So all the prime numbers. You can even set the range also, right? How do you set the range also? So for example, you can set the range from something like this, right? I'll just set it as n and m, all right, n and m. So I'll come here and I'll set the range called as percentage d here. So I'll read two things, percentage ampersand m, I will tell it, right? Here I'll start from n, and I'll end till em, right? Simple thing, right? So this is the range, I'll tell it. So I need to enter two numbers, right? I need to enter two numbers. I'll come here, I'll tell it as dot/a.out. I want it from 10,000 to, I want it from 20,000. So how many prime, which all the numbers are prime numbers, right? So these are all the numbers are prime numbers. I can get it. But even I can count also, no problem with that. So these are all the numbers, you can get it for prime numbers, right? So there are so many numbers, right? Starting from in 10,000, 10,007 is a prime number, right? So all the numbers you can get it for here like this. Done, guys? So you can go for here, and this is your end program. So to find the range, to find it out the prime number from the given point to given end point. Okay, that's it for today. I know at the last I was like quite into it, so you can just go for it, and I'll be sending the recording, and you can trace it. Nothing big hectic. You got all the points, which are all the lines you wanted it. Okay, there is no line which is not understanding to you. All the lines we have done it. Got it? Okay, that's it. That's all for today, and we'll see you tomorrow at same time 8:30. Before that, you can have a look onto this and start coding this. Okay, today's agenda was only so much. It's not all about the prime number. It's all about how you start the program and how you end it, right? So I'm not telling this is the end point. Even you can reduce this one also. Got it? Okay. Thank you guys. Thank you so much. And see you tomorrow at same time at 8:30. And if any queries you have it, you can ask it. Okay, the session is open for the queries.